Good Monday morning! Today I am going to take a look at templating languages like Handlebars, or the templating language that is built into Vue, for example. And I'm going to compare the templating languages to a native JS approach, where JavaScript plays the role of the templating language. This is the approach that React uses, for instance. When you're advocating for using a templating language, you often cite two main benefits: that templating languages are expressive and declarative. I'm going to talk about those benefits, but I am also going to talk about three costs that come with using templating languages. Templating languages add complexity to your stack, they add a social cost, and they result in a loss of tooling. That is what we're going to talk about today. I am MPJ, and you are watching Fun Function. If we look back in time, say 5 years ago or so, the industry standard way of rendering DOM was to use a templating language to glue your business logic together with your DOM. Then, a couple of years ago, do you remember how old React is? Like 3-4 years? Anyway, React arrived on the scene, and it did away with templating languages. Instead, it used just native JavaScript in playing the role that templating languages had before. I just want to be clear here that we're not concerned with JSX or the virtual DOM in this video. JSX is a thin layer on top of the native JavaScript that React uses, and we're not really concerned with that. We're concerned with the fact that it's still native JavaScript under that very, very thin layer. It's not consequential, and also under React doesn't technically generate real DOM, it generates a virtual DOM and then diffs at it. Like, we're not really concerned with that either in this video. What we're talking about here is like the pure custom templating language, and we're comparing that to the native JS equivalent. The native JS approach has been gaining a lot of traction in recent years, but the templating languages, we've used them for a long time, and a lot of developers are not convinced that the native JS approach is a step forward. In this video, I'm going to talk a little bit about the cost and benefits of templating languages and give you like a sense of the thinking behind the native JS approach that React uses and why they have moved away from templating languages and why a lot of people do it. Expressive. Templating languages are very expressive because unlike JavaScript, that is a general purpose programming language, templating languages are designed to do just one thing, and that is to render HTML. Declarative. Templating languages are designed to encourage declarative interfaces. By the way, if you're not sure what declarative programming is, you might want to check out this video that I made, and this video is going to make much more sense. All technologies have some benefits, and all technologies has some costs. The first cost of templating languages is complexity, because you are simply adding an entire little language to your technology stack. The second cost is social cost. Anyone working in your codebase now has to learn this little extra language in addition to JavaScript. And the third cost is loss of tools. If you're using a templating language, you're throwing away all the power of JavaScript. Not just the language itself, but also the ecosystem, all the libraries written in it, and all the tools and linters and editors and IDEs. Those are the costs and benefits I'm going to be talking about today, and well, let's dive into each one. So, expressiveness. Templating languages are very, very expressive because they are, unlike JavaScript, they are designed to do just one thing, and that is express the rendering of HTML. Templates are essentially a domain-specific language. They're in the same category as SQL or regular expressions. They are very custom languages designed to express a very, very specific thing in a specific domain. From here on out, I'm going to show you a bunch of examples. I'm going to show examples of templating languages compared to equivalent examples in the native JS approach. I am very intentionally not going to be using any real live technology here, like React or Vue or Handlebars. And the reason for that is that a lot of the points that I'm going to try to make are related to familiarity and understandability, and it will just be skewed if you are familiar with the syntax of a technology already. But you can sort of think about this example as kind of React without JSX and kind of Handlebars. And we're going to assume that both of them has the same rendering trait. So like imagine that both of them are rendering a virtual DOM and all the rendering characteristics are the same, because those are just implementation details. We're not concerned with that in this video. We're concerned with the general form of a templating language versus a native JS approach. All right, we're going to now look at the code of the templating language. And remember that we are now, for now, looking at this from an expressiveness standpoint. I'm going to be silent for 15 seconds to allow you to look at this example. Try to understand what it does. All right, so let's go through it. The template has this div, it's called the prices container. And this in turn, it contains this unordered list with some items here. Note that it only shows the list if it has some items in the list. Otherwise, it will show a paragraph here with the text no items found. Inside every item, it shows the price, and it also runs it through some kind of format currency transformation. You know, this is probably just to convert this from whatever this is, probably an int, to some nice currency string. I would like to draw your attention to one thing in this example, and that is the fact that you could probably, by just looking at this, figure out what it did. Even though this is a language that does not exist, you're not familiar with it up front. Even if you were not even familiar with the concept of templating languages, this would probably still make sense. It doesn't try to be a general purpose language like JavaScript, and that allows it to just throw away a lot of power and a lot of features in order to gain this readability and expressiveness for this very specific case, HTML rendering. And now we're going to look at another example that does exactly the same thing, but it does it using a native JS library, and that looks like this. I'm going to be silent again for 15 seconds and let you try to understand it. Alright, so let's walk through this. This is render prices container. It returns a div, and it has the CSS class list container. And this is a great example of how a templating language is extremely expressive. Because here with JavaScript we have to use class name, because JavaScript is not designed just for this. It's a general purpose programming language, so it has the concept of a class. That's another thing in JavaScript. So that's a reserved word that we can't use in this context, so we have to use the property class name instead to make this work. Inside of the div, if the items array has a length, it will return a UL, unordered list, and that unordered list inside of itself has a list of list items. So it just maps through the list items and it returns a list item for everyone, and it, just like the template example, it formats the currency before putting it into the li. And if item.length is falsy, 0, it will return this paragraph with the text "no items found." So all of this is just JavaScript. There's no special language additions that we have done here. It's just pure JavaScript. This looks a lot less like HTML than the template example. Even though it is JavaScript that we are familiar with, it still feels a little bit alien and convoluted because we have to sort of simulate the HTML rendering in our heads. We have to spend a little bit more brain power to figure out what HTML this results in. Here it's a bit more like we just have to remove these from our heads and then we have the HTML. It's the processing that we have to do in our heads is slightly less. Now, I would say that this is not a huge difference. You might even actually call this a small difference. This is absolutely not rocket surgery, but we still have to give it to templating languages here that they are expressive. They are meant to express this thing, HTML rendering, and they do it better than JavaScript natively does. Let's move on and talk about declarativeness. If we look at both of these examples, they very clearly dictate what is being rendered. Neither of these examples is very concerned with how. More specifically, there is no imperative programming going on here. There are no variables being assigned, there's no state being mutated, it's just declaring what things are. So, both of these examples are declarative as opposed to imperative. And that is a very good thing, because declarative code is almost always easier to reason about than imperative code, and that holds especially true when it comes to rendering. In addition to being declarative, there's also very little logic going on in them. They are very easy to reason about, there's not a lot of stuff. This is true for both examples, but the key difference here between the templating language and the native JS example is that the templating language has to be this way. There is no way to do imperative programming in the templating language. In the JavaScript example, we could do all kinds of crazy things, access global variables, start maintaining state, but in the templating language, you can't do that. You cannot create variables and stuff like that. And in the templating language, there simply isn't a lot of language constructs in general. So your code tends to be pretty minimal because there's just not a lot of programming you can do. And this is by design. This is the intent of templating languages. Templating languages are trying to encourage, even enforce really, a minimal and declarative view. Templating languages are trying to remove the ability from the programmer to do imperative, elaborate things in the view. While I buy the whole expressiveness thing, I really don't buy when people talk about templating languages as encouraging declarativity. I feel there is a problem with that line of reasoning. Let's think about this for a minute. We have this problem. Our views contain too much imperative and elaborate logic. We feel like this should be in the business logic instead. So we can try to solve this by introducing an entire little language into our stack where you can't do imperative and elaborate programming. Or we can just stop doing imperative and elaborate programming in our views. Just stop doing it. Just don't put imperative, elaborate logic in your views. Just stop. That is a much simpler solution than introducing an entire little language to your toolchain. In response to that, you might say that, but what about the junior developers? They have not fully grasped the concept of separation of concerns yet. Having a templating language might be good, like training wheel sort of thing, to keep them from doing damage to our project. But I don't really buy that argument, because you still have the capability to do dumb things when it comes to separation. You have just moved it one little layer away from the templates. If you have a team member that doesn't understand separation of concerns, no amount of technical safeguards are going to help you. What you need to do is to help and educate that person, or you're going to have a big problem on your hands. So templating languages are built to encourage declarativeness in views, but I think a lot less convoluted solution is to just write simple and declarative code in JavaScript, rather than dragging an entire little language into your stack to prevent you from making the mistake. And this leads me to the first cost of templating languages: complexity. No matter how you cut it, a template language is a programming language. That is a reasonably big, complicated thingy to pull into your project. Your project as a whole is now more complex, because a templating language isn't really the kind of component that removes a lot of complexity. So you sacrifice some simplicity in order to get the templating language. Now, it should be said that this is a personal value statement, in the sense that I'm a person that values simplicity very, very high. Like probably higher than most people. I've once or twice gotten the feedback that I should accept more complexity into solutions. There are absolutely developers that do not mind this extra complexity. They feel that adding a templating language to your project, that's not a big deal, that's not a big component. They feel it's well used, it's popular, it's free, it's maintained by a third party regularly.15 the big deal? But that's not how I view it. I view it as like 1,000 tiny cuts kind of thing. My philosophy is that the more thingies that you add to your project, or whatever in life really, the more things you add that can go wrong, the more things will go wrong. When we add a new tool to our tool chain, that will add complexity. And I mean, that might be okay. I really must stress that. It might be okay. Like, we need to be able to absorb some complexity, of course, because we need to, solve problems, and some problems are complex in a very real manner. We need to have tools, and we need to absorb some complexity. But the point I'm trying to make is that when you add something, it must pay for its own complexity cost. So a templating language might not be the biggest complexity cost in the world, but the benefits that a templating language brings in, I think that they are very small. And I think that the complexity trade-off, the return of investment here, is a bad deal. And complexity is only one of the costs of templating languages. There's also a social cost. I talked before about the fact that a templating language is a domain-specific language, a DSL. Other languages in that family is SQL, which is used to describe data access, and regular expressions, which is used to describe string pattern matching. They are the same family, but there is an important distinction, and that is that regular expressions and SQL are relatively standardized. But templating languages are not like that. There are many different ones, so new developers coming into your project are not very likely to know the particular one that you're using, so they are going to have to spend some time learning it and learning how to work with it. Let's go back to the original template example. Now, as we concluded before, this is very expressive, so it's easy to figure out what it does. It's very easy to read and understand that. But that does not mean that we have understood the language. That we know how to read it doesn't mean that we know how to write it. Let's say that you had the assignment that we wanted to pad the price with zeros if it's less than 10. Let's say that we already have the function. It's pad price with zeros or something like that. How do we get that in here? I could probably figure out that it might be something like this, but I don't really know how to actually get the function into the system. I need to figure out how to register this function in the templating parser. I probably need to do some kind of plugin thing or something. And this is only because we're lucky, because we have this example here. Like, if we imagine that this was just the thing and we have not seen this syntax before. And templating languages, they're a bit sneaky this way. Because they are easy to read, they feel approachable, but that feeling goes away once you start trying to write them. Then you realize that they are not really as intuitive as they first seemed. And you might say, oh, what's the big deal? Developers just hit the docs, find it, Google it. Developers do this all the time. It's not rocket surgery, you're a developer, what's the big deal? Well, let's have a look at the same problem in the native JS library. And since this is just JavaScript, and we know JavaScript, we can just add the function. Done. We don't need to learn any plugin system. We just include the file. It's just normal JavaScript. We didn't need to learn anything. We could just make the change straight away. So yeah, it's not rocket surgery to look up some docs and add some plugin, but it's a problem that only exists because of the templating language. A native JS library does not have this problem. You don't have it. You don't do that work. A template language has a higher social cost than a native JS library. So a template language has a complexity cost, a social cost, and I want to talk about a third cost, and that is the loss of tools. JavaScript is a very mature language. Very fast and mature engines, an incredibly vast wealth of libraries, many mature editors and IDEs, and a lot of code analysis tools. When you develop in another language, you lose access to all of that, and you are limited to whatever ecosystem is for that specific language. For example, let's have a look at the native JS library example again. I can paste this just into my editor, and I have access to everything that whatever fancy pants bells I have for my JavaScript development environment. Code highlighting, linting, contextual, autocomplete, stuff like that. I mean, if I change here, it immediately figures that, oh, something is wrong. If I do the same thing here, like, it has no idea because this is a string. There might, of course, be plugins and stuff for this templating language that you can install, but you've now added one extra thing for your developers to install, and that tooling is also very unlikely to be as mature as their JavaScript equivalents. You also lose access to the power of the language itself. Template languages are limited. In fact, this is by design. Like we talked about before, it's to keep you from doing elaborate things in your rendering. But there are things that are not possible to do in the templating language, but are still simple and minimalist enough to want to have in there. Let's say, for instance, that we wanted to, I don't know, calculate the total of the items. Let's do... In a templating language, you would probably not be allowed to do a sum operation. If you're not familiar with reduce, this example is probably gonna make you, what is this? There is an episode here on reduce. It's very simple. It's used to sum things often. But the point, in our templating language, you are probably not allowed to do a sum operation. That's something that the philosophy of a templating language is to relegate to outside the template. It's a bit of an academic discussion if sum of items is business logic or view logic. I think it definitely can qualify as view logic. Others might disagree. I don't know. What do you think? Comment. If you do agree that summing items is view logic, then you can see how a template language makes your life a little bit harder. Another thing that JavaScript gives you for free is composition. For example, let's say that I had different types of items that could be in the list. So I want to reuse the list view container, so to speak, but I want to be able to shove different kinds of items in there with different kinds of templates. Have a look at this and try to first wrap your head around it on your own before I explain how it works. Alright, so let's have a look at the example. Render list, it's more or less the same function from before, but we have given it a general name and we have modified it to accept a render item function here. So render item is now the thing that goes into the mapper. So if you remember, the example used to look like this before, but we have now broken it out into these variables. So in order to create a function that is equivalent to what we had before, we use bind to query render price list. And what that means is that we call bind on render list, and we call bind with render price item as an argument, and that will return a new function from bind to render price list where render price item has been fixed as the first argument of render list. It's kind of permanentized it. So render price list, it's now just called with items. This has now been fixed as the first argument. If currying is a new concept to you, I have an episode on that here. Currying. So don't dismiss this as weird because you don't know what currying is, because currying is amazing and you should learn it. So notice how all of this is just plain JavaScript. The div, UL, and P things here, they're the same from before, but notice that there's no concept of a component being introduced here. And this works because we're doing everything with just plain functions. And plain functions are simple and composable. This composability that we get completely for free here needs to be re-implemented in a templating language, often in the form of components. Components are great, React does have them, but when working with React you can often get away with just using simple render function, and that is nicer because it is just much simpler. And those were my thoughts. In summary, template languages are good at expressing HTML rendering. That's what they are built for. Template languages aim to encourage minimalistic and declarative programming, but you can just do that anyway in JavaScript. The cost of templating languages is added stack complexity, social cost, and lots of tools. You have just watched an episode of Fun Function. I release these every Monday morning, 0800 GMT. If you don't want to wait until next Monday, you can watch this episode that the brain in a jar that Google brands as machine learning has selected for you. I am MPJ. Until next Monday morning, stay curious.